Hello there, Mr. Sutton here, bringing you the IM3 Chapter 7 Quiz 1 Extra Practice Solutions on Special Right Triangles and Pythagorean Theorem. For this problem, we're trying to find the missing side of this triangle. Now, since we have two sides of this right triangle already, to find the third side, we can just use the Pythagorean Theorem. A squared plus b squared equals c squared. And c is always going to be the hypotenuse, which is across from the right angle. So c is going to be this 14 here across from that right angle. And then a and b are just going to be the other two sides in whatever order you want. So for a, I'm just going to use the bottom side here, 6. So we'll write 6 squared plus, for b, I'll use the other leg, so x squared, equals my hypotenuse of 14 squared. At this point, I just have to solve for x, which means I'm going to have to isolate the x squared. So I've got 14 squared, which I happen to know is 196. And then 6 squared is 36. 196 minus 36 is 160. So that's what x squared equals. Now they do want the answer in simplest radical form. So when I square root this, I'm going to start simplifying it. The biggest perfect square I can think of that goes into 160 is 16. 16 times 10. So I'll split this up into radical 16 times radical 10. And then I can square root the 16 to get a 4. So then 4 radical 10 would be my final answer. For this problem, we want to know if these three sides form a right triangle. The only way to know this is if these satisfy the Pythagorean theorem. So let's write that out. A squared plus b squared equals c squared. Now when you're plugging these sides in, the c value is always the longest of the three sides. I mean, they happen to be written in order, but even if they weren't, c would have to be the 15 out of this bunch because the hypotenuse is always the longest side of the triangle. So we've got either 6 or 14 squared, whichever one you want. I'm going to go with 6 for A. So 6 squared plus 14 squared equals 15 squared, question mark, because we actually want to see if this is true or not. So let's evaluate each side. 6 squared is 36. 14 squared is 196. 36 and 196 is going to give me 232. And then 15 squared, I happen to know that that is 225. Now 232 is not the same as 225. If these had been the same, then we would have said, yes, these three sides form a right triangle. Since these are not the same, we're going to say, no, this is not a right triangle because it does not satisfy the Pythagorean theorem. On this problem, trying to find the area of this right triangle, in order to get the area of any triangle, we need to do 1/2 base times height. And we've got the height here, it's 8, but we don't have the base down here. So we're going to have to find that, and I'm going to call that b just so I can refer to it easily. Now the good news is we do have a right triangle with two sides given. So to find that base, that third side, we can just use the Pythagorean theorem. A squared plus b squared equals c squared. So c, I know that's going to be across from the right angle automatically. So that's this 12 here. A and b could be either 8 and b, either one, doesn't really matter. I'm going to let a equal 8, so I'm going to write 8 squared. And then, I mean, hey, might as well just let b equal itself this time around. Be weird to call a b, right? So I'm just going to write plus b squared equals my c value of 12 squared. So isolating the b squared, we've got 144 on the right side, and we're subtracting 64, 8 squared, from the left side. So that's going to be 80 that b squared equals. And since I'm going to have to put my final answer in simplest radical form, when I square root this to get b, I am going to put this in radical form, simplest radical form, just so I get that out of the way. So 80, the biggest perfect square that goes into 80 when I square root that, is 16. 16 times 5. So I can write b equals radical 16 times radical 5, which I can simplify to 4 radical 5. All right, it's time to use my area formula, 1/2 base times height. So I've got 1/2 times the base I just found of 4 radical 5 times the height that they already gave me of 8. And putting that all together, half of 4 is 2, so we have 2 radical 5 times 8. And then 2 radical 5 times 8 is going to be 16 radical 5. On this problem, I've got a single side of a right triangle, and the other angle they gave me is 45 degrees. Well, if that's 45, then that means this third angle has to be 90 minus 45, so also 45. And, hey, this is proof that this is a 45, 45, 90 triangle. It's one of our special triangles. So I don't have to use SOHCAHTOA on this. I can actually use this reasoning instead, which is good because they want the answer in simplest radical form, and SOHCAHTOA usually just gives you decimals. So this is the way to go on this problem. So now let me write out the ratio. That would be s to s radical 2. That's the ratio of the sides of one of these. And let me label the triangle with those three expressions. So the s's are always across from 45 degrees. So we have an s over here across from this 45, and another s over here across from the other 45. And then always across from 90 degrees, we have the s radical 2 side. So to figure out all my sides, I just have to figure out what s equals. And to do that, I just have to let one of these s expressions equal whatever constant they gave me on these sides. Now, the only side they gave me was this 4 radical 2 side, and that equals the expression s. So if I write s equals 4 radical 2, I've actually already found the value of s, which means that I have everything I need to find the other sides. So I'm just going to plug in 4 radical 2 for s to get x and y. X up here, it looks like, is equivalent to s radical 2. So that means we can write x equals 4 radical 2 times radical 2. Radical 2 times radical 2 is 2. 2 times 4 gives us 8. So that's my x value. And now for the y value, looking back here at what I labeled next to y, I said that y and s were the same thing because y was across from 45 degrees. So if y equals s and s equals 4 radical 2, that means that y equals 4 radical 2. For this problem, we want to find the value of x and y in simplest radical form. Now, the key on this one, you'll notice that we have a right triangle. One side is already given, and the other angle here is 60, which is one of our special angles. If this angle is 60, the other angle here must be 30, and we have a 30, 60, 90 right triangle. We know the ratio of this, the ratio of the sides across from these angles is always s, s radical 3, and 2s. So I'm going to label my triangle with those three expressions, and let's see what happens. So we've got s across from 30 degrees, that's down here, and then s radical 3 across from 60 degrees goes next to the y over here, and then finally 2s across from 90 degrees goes next to the 8 radical 3. I have to solve for s, and then I can get anything I want out of this triangle. And the only way to solve for s is by taking one of these expressions and setting it equal to an actual number. The only number they gave us was 8 radical 3, and the s expression next to that is 2s. So I write 2s equals 8 radical 3, and then if I want to solve for s, I just have to divide by 2, so we get 4 radical 3 for my s value. Now that I've got s, I can plug that back in to get my x and my y value. X here is next to the s expression, so we can write x equals s, and since this is s up here, we can just write x equals 4 radical 3. Now for y, that one's a little trickier. Y is the s radical 3 side, so if y equals s radical 3, then that means we have to do 4 radical 3 times radical 3. Radical 3 times radical 3 is just 3. 3 times 4 gives us a y value of 12. On this triangle, we notice that we have 90 degrees and 60 degrees, so our other angle is 30. That means this is one of those 30, 60, 90 triangles, and we know that the side ratio of these is s, s root 3, and 2s. So let's go ahead and put those on this triangle in the appropriate sides. So the s side is across from 30 degrees, that's this side down here. S root 3 is across from 60, so that's over here. And then the 2s side is always the hypotenuse, which is this third side. All right, now taking a look at what they gave me for information, the only constant they gave me, the only known value is this 8 radical 3, and that goes with the s radical 3 side. So I can write s radical 3 equals 8 radical 3. Solving for s, if I just divide both sides by radical 3, I get s equals 8. And now I can use that to figure out the values of x and y. For x, I know that that equals s. That's next to the s expression here. And since s is 8, that means that x is 8. Now for y, we know that that's equal to 2s in this problem. So that means that y is going to equal 2 times 8, or 16. For this problem, the key thing to notice is that we have a right triangle with 45 degrees. That means the other angle is also 45, making this one of those special 45, 45, 90 triangles. Now you might remember the ratio of sides in this is s, s, and s radical 2. Let's go ahead and label the triangle with those different sides. So the s sides are always across from 45. So we've got this side over here is an s, and this side over here also an s. That means that my hypotenuse, my 90 degrees, is this s radical 2 here. The only side that they gave me was this 4 radical 2. Since that's equivalent to this s radical 2 part of our ratio, we can write that s radical 2 equals 4 radical 2. And from that, I can just divide both sides by radical 2 to get s equals 4. Now that we know s, we can figure out the values of x and y. X and y both have a value of s, so that means that x and y are actually both this 4 that we just found. In this triangle, we've already got 90 degrees and 60, so the other angle is then 30, making this a 30, 60, 90 triangle. And that means the ratio of the sides is automatically going to be s, s radical 3, and 2s. The s side is across from 30, so let me put a little s down here to remember that. S radical 3 is across from 60, so this side over here with the x is s radical 3. And then finally, this y side here, the hypotenuse is going to be this 2s side. It's always across from the 90 degrees. Now looking at the information they gave me this 8 radical 3 down here. And I wrote that that was the s part of my ratio. So I can write that s equals 8 radical 3. And now that I know the value of s, I have enough information to figure out x and y based off of that. We know that x is equivalent to the s radical 3 part of this ratio. Since x equals s radical 3, that means that x equals 8 radical 3. Radical 3. So I'm plugging 8 radical 3 in for this s value, and I still have this radical 3 out here waiting to be multiplied. So radical 3 times radical 3, that's just 3. So we really have 8 times 3 going on here, which is 24. Now to get the value of y, we know that y and 2s are equivalent. So that means y is going to be 2 times this s value of 8 radical 3. 2 times that's just going to give me 16 radical 3.